Installation of standalone DC system. How to connect the standalone DC system along with the solar panel. Then how to the solar energy is converted into electrical energy, we are going to check today. So for standalone DC system, we want solar panel, we want charge controller, we want battery, then we want DC load. We want DC load. So how to connect the charge controller? In charge controller, there are 6 terminals will be there. 2 terminal for the solar panel. So solar panel is connected through the wires. This wire positive and negative wires. When you are connecting, you want to see the positive and the negative terminals. The red wire should be connected with the positive terminal. The black wire should be connected with the negative terminal. Other 2 terminals are battery terminal. Here also polarity marking is there. This is a positive terminals of the battery. It should be connected with the positive of the battery. Then black wire is a negative terminal. It should be connected with the battery negative terminal. Now you can see here. Now the solar panel is working. It generates the voltage and supplying energy is transferred from the solar panel to battery. Now there is no load. So now the battery getting charging. So we are connecting 12 volt to battery. So it will charge the 12 volt battery. If you want to connect 24 volt, we can connect 2 battery in series. If you want to 48 volt, we can connect 4 battery in series. It automatically set the voltage because this is a solar charge controller. It will control the level of charging. It will also prevent the overcharging. It also prevent the low charging also. Okay. When you connect the load, we will get the 12 volt output load because we are using 12 volt battery. We are getting the 12 volt at the output. We can check the whether output is coming or not. We can check it. Yes. Connect the 12 volt lamp load. Give the load. No. This is the 12 volt lamp. It is 12 volt, 12 watts DC lamp. We can use this lamp whether the DC output is coming or not. Yes. Connect the load with the load terminals. Yes, you see now the load is working. The load is working. So if you are going to use 24 volt load, then we have to connect 2 batteries. Automatically the solar charge controller will adjust the output voltage automatically. Okay, this is the completion of first exercise. After that, everyone has to remove the connection. Again, you have to connect the connections. Okay, thank you. Connecting a standalone AC PV system. So for that what we want? We want the solar panel, we want the charge controller, we want the standalone inverter, then battery, then lamp load. So this is a solar panel. It is connected in series. Now the solar panel is connected with the charge controller. Yes, that is negative and positive terminal connected with the charge controller. Then battery. We are using 2 number of batteries in series. Already I told, according to the battery, the charge controller will regulate the output voltage. Now, the charge controller charge the 2 battery which are in series. So, it gives the 24 volt output. Now, we are connecting the inverter. In the standalone inverter, there are 2 terminals for the battery, that is output terminal, then AC output. We are getting our AC output. So, now the solar panels are connected. The power generated in the solar panel is used to charge the battery to the charge controller. Then output supply is connected with the inverter. Then inverter invert the DC voltage into AC voltage. Then AC voltage is given to the load. Now we can check whether it is working. Yes, it is getting almost 25 volt. We charge the battery. From the battery getting charging, the output voltage is connected with the output load is connected with the inverter. From the inverter, we have to switch on the inverter. Then AC supply is coming. We are checking the AC output. Yes. Now the AC bulb is working. It is a 40 watts AC bulb. It is working. Now we can on one more bulb. Yes. Now the solar energy generated by the solar panel is used to charge the battery. Power also stored in the battery. At the same time, the DC is inverted into AC. Now the AC load is getting on. This is the end of our second exercise. Installation of on-grid PV installations. To install the on-grid PV installation, we want solar panel. It is available in the rooftop. Then we want on-grid inverter. Then load. We have the lamp load to check the input and output. It is import of energy or export of energy. So we have net meter also. It is a small net meter, single phase net meters. Now we can see how the connection are given. The EB supply is coming, that is a grid supply is coming to the net meter. Then this output is coming to this extension, this socket. Socket is connected with the extension board. We are connecting the load in the extension board. If you switch on the load, yes, come somebody switch on the load. Yes, and now the energy is coming from the grid through the net meters and going to the load. Now the inverter is not connected. So now you can see it is blinking. So in the net meters, there is a 4 parameters there. One is a total energy. Second one is a imported energy. That is how much energy we are taken from the grid. Then third one is a export energy. How much energy we are sending back to the grid. Then if you want, you can reset. After reset, how much energy we are consuming, it will show. Okay. Now we are going to install the inverter. So this is the grid tied. That is an on-grid inverter. In this inverter, there are 2 points is there. One is a positive, negative. It should be connected with the solar output. That is output from the solars. So it is a negative terminal. It is a positive terminal. We are using one ammeter in series with the positive terminal to measure how much current the solar panel is given. We can measure. Then if the grid tied inverter is connected with the grid, then only it will work. Otherwise, it will not work. So how it is connected? It is connected through this power card. It is connected with the sockets. Okay. This is the positive and negative wires of the solar panel coming through the conduit pipe. We have one more MCB, that is a DC MCB for safety purpose. Yes, now you can switch on the DC MCB. Now the DC voltage is coming here. Check the positive and negative terminals of the solar panel. This is a positive. Yes, red wire has to touch negative. How much voltage is coming? Yes, it is 44.5 voltage. It is coming from the solar panel. Yes, taken. This inverter is designed for 22 voltage to 60 voltage DC. So we are connecting only one panel. If we are connecting 2 panels, we will get almost 90 voltage. So this inverter is not suitable for 90 voltage. It is suitable up to 60 voltage. So we are connecting only one panel, 540 watts. Yes. Now just we have to give the grid supply to the inverter, then it will work. Now we can see from the solar panel, now it is connected with the grid through the on-grid inverters. Now from panel, now we are getting the current. Now it is increasing slowly. Depending upon the load, it will increase. Okay, now what are the energies available will go into load. What are the excess energy will go into the grid. You can see here, now we can switch off the load. What will happen? How much energy are generated in the solar panel is connected to the grid through on-grid inverter is going to the grid. Here you can see there is one arrow mark is there at the end. If the arrow mark is coming, that is meaning is the supply is export to the grid. Actually, our panel is 540 watts. If you on the 500 watts lamp, what are the energy is generated is going to load only. It is not going to the grid. Okay. If you switch off the load, then what will happen? Whatever the energy is generated is going to the grid. That time you will get this arrow. Okay, is there any doubt? It is a simple connection. We have to connect the grid with the inverter. Before connecting inverter, we are connecting some loads. Then we have to connect the solar panel. Before connecting solar panel, we are connecting one ammeter to measure how much current is coming. Very simple connection. Is there any doubt? Okay, after that, you have to disconnect. Again, everyone connect the same circuit and check it. Thank you. Identification of parts of 100 kilowatts rooftop panel. This is our 100 kilowatts rooftop panels. What is the panel? It is a panel means it is a series combination of solar cell. For example, this is a panel. If the solar panels are connected in series, what is called as string. So this is a single string. This one is a single string. If you see here, the solar panels are connected in series. The negative terminals is connected with positive. Again, the negative terminal of second solar panel is connected with the positive terminal of third. Like that, there are 18 solar panels are there. 18 solar panels are connected in series. Now we will get only 2 wire as a output. That is a common positive wire and common negative wire. This is a string. So there are 11 strings are there. In each string, there are 80 panel is there. In 10 string, only 180 panels is there. Then 11th string, we have only 6 panel. Totally 186 panel is there. A single panel is 540 watts panel. If you add all together, it is almost equal to 100 kilowatt solar panels. Now we can see how much wire is coming in this rack. You just see how much wire is coming. Only 2 wire. Even there are 18 panels there. All the panels are connected in series. Only common positive and the negative terminals are going to the inverter. Hereafter we will see where is the inverter. Any PV system having capacity of 50 kilowatts or more should have some monitoring equipment or device. So here our system is 100 kilowatts. So we are having 2 monitoring system. One is a pyranometers, which measure the solar irradiance continuously and record it in the memory locker. Here one more is a moisture and humidity sensors. It will also continuously monitor the humidity and moistures and then record in the data locker. It is available in the inverter room. Dear student, this is our inverter. Actually, we have the 100 kilowatt solar panel. We have 2 inverter. One is a 70 kilowatts. This one 70 kilowatts. Another one is a 30 kilowatts. We have 11 strings. 11 strings of solar panel. All the strings are coming here. For 70 kilowatts, almost 7 strings are coming here. The strings are connected to this is a terminal strip through the DC fuse. The first one is a DC solar fuse. All the strings should be connected in series with the DC fuse. Then it may be connected series or parallel. Then next is a thermal strips. Okay. Then it will go to the inverter. When it is connected with the inverter, some surge protective device should be connected. Because when the surge is coming or any lightning is falling on the solar panel or cable, then the surge voltage will travel to the inverter, then to the system. It will affect the system. To avoid the system, we generally using the surge protecting device. There are 6 surge protecting devices there. So it is generally connected with the in parallel with the strings. It has 3 terminal, 2 terminal, one for positive and another one for negative. Third terminal is here. The earth terminal should be connected with the earth. Directly it connected with the earth. It is a 70 kilowatts inverters. What will do? It will invert the DC voltage generated by the solar panel into AC. Then inverter is connected with our main system grid. This is 70 kilowatts inverter. Another one is a 30 kilowatts inverter. Dear student, this is our 30 kilowatts on grid inverter. 30 kilowatts on grid inverters. In this, 4 sinks are connected here through the DC solar fuse, terminal connector and surge protector device. Through this common box is called as array junction box. The combined box is called as array junction box. From the junction box, it is connected with the inverter. This is a grid die. That is an on grid inverter. This inverter invert the DC voltage into AC and connected with the grid. Thank you.